Hello scientific people. Today we will be discussing about some of the another brain teasers in optics, in concave mirror especially. And what do we have a situation over here? We have a concave mirror which is kept like this on a table, suppose like this. So you can consider this my hand to be a concave mirror. So I am placing the concave mirror like this, right? Okay, and this is the pole. This point is the pole, this is the principal axis, this is the center of curvature, this point. And what am I going to do is, I'm going to place a very point sized object, a very small dot like object. So a dot like object on C. So I know that when the object is placed at C, the image will be also formed at C. And we know that suppose two incident rays, they are coming out of the object and falling on the concave mirror. Now we know that after reflection they are going to retrace its own path. So the reflected rays would be moving back, and again the reflected rays would be meeting at point C. So the image would be formed at C. Real, inverted, everything we know. Now in this situation what I have done is, I have filled some water in this part. So now this convex mirror, right, this convex mirror itself is filled with water. This is the non-reflecting part. Now this is the center of curvature of the mirror, and same object is kept over here. Now since I am filling this concave mirror with water, I need to know that where is the position of the image now. Has it shifted, or has it was it at the same place? So let's analyze the situation. So the question over here is, after filling the mirror with water, where is the position of the new image? Is it there only, or has it shifted, right? Okay, so for that I need to make two incident rays like this. So this is incident ray number 1. This is incident ray number 2. Now since this is the layer of water, so what is going to happen is, the rays of light are going to get refracted. So this would be the normal, this is the normal, right? Normal is always perpendicular to the surface. Now this is going to bend towards normal. So this is your refracted ray, and again it is going to bend towards the normal. So this is the refracted ray. This is the point of incidence, and we know that the normal always passes through C, and the normal always passes through C. So here again the rays of light will get reflected by the same angle, so like this, and this ray of light will also get reflected like this. Now from this point again I need to draw normal, and this time instead of going straight they will bend away from the normal, So two refracted rays, they are meeting over here instead of going straight away from the normal. So earlier the image was formed here, now this is the position of the image. Okay, fine. So that means we find the shifting of the image towards the concave mirror. Now question number 2, we have again a very good problem, and comparatively an easier one, that a concave mirror of focal length f and radius of curvature is immersed in a water. So suppose you have a concave mirror and whose radius of curvature is r. So we know that r by 2 is equal to f, right? So we know the focal length of the concave mirror to be like this. But now suppose this is water. Now inside the water, if I immerse the same mirror, then what will be its new focal length? Suppose the new focal length is f dash, but the focal length is not going to change because this distance, this radius of curvature remains the same only. So if the radius of curvature remains the same, then radius divided by 2 is the focal length. So no change in the radius of curvature, no change in the focal length. So whether it is a concave mirror or convex mirror, when you dip it inside the water or oil or any other medium, the radius of curvature and the focal length of the concave mirror remains the same. Okay, so let's move on to the new problem. Next problem. Now here we have a concave mirror, and this is C, this is F, And we know that by the rules of image formation, the image would be beyond C, enlarged, real, inverted, and so on, right? What am I going to do is, I am going to cut off this part of the mirror. So I only have the upper part of the mirror, which is over here, and so the upper part of the mirror stays, and the lower half part of the mirror, I am removing it. Now the question is, where is the image formed, and what would be the change in the image, and how many images would be formed? So our answer remains the same, only the lower part of the mirror is not taking part in the image formation. So that means the rays which will be reflected from here will not merge to form the image, but rest the image would be formed by the upper part of the mirror. So what happens is, these incident rays which are going to hit the upper part of the mirror, they will get reflected and form the image. So what is going to happen? This part, after removing, the rays which are reflecting from here will not be coming over here, so only the brightness of the image changes, and we can expect the image to be little bit fainter than what it was. So the image is again formed at the same point, right? The brightness of the image changes, right? It decreases actually, otherwise everything remains the same. So here again, what am I doing is, I am removing the upper part of the mirror and the lower part of the mirror stays. So what happens is, the object stays between F and C. This is C, this is F, and the lower part of the mirror stays. Now many of us, we will be definitely getting confused that the rays are not going to get reflected, and finally no image would be formed. But that answer is incorrect. The rays which will be hitting this part of the mirror, they will again merge somewhere over here. So again the image would be formed beyond C, inverted, real, enlarged, as well as the brightness of the image would be lesser than this one, because the upper part of the mirror is not there for the formation of the image. So the lower part of the mirror is going to contribute, and exactly in all these three situations the image is formed at the same point, but the brightness of these two images is less than this one. Now here is a typical case. I have shifted one of the mirrors after cutting it from here in this direction. So both the full mirror was like this. Then I had cut the mirror from here and I had shifted the mirror over here. So now what happens is, when I finish this circle, I will get the center of curvature. Suppose say this is mirror 1. So this is center of curvature 1 for the first mirror, and let me call this mirror as mirror number 2, and when I finish this circle, when I finish the circle over here, I get the center of curvature 2 over here. So now I have two different center of curvatures. So what is going to happen is, I will get two different images. So let's put the object somewhere over here. Now this object is at C1 of the first mirror, so the exactly same sized image is formed over here. Now this object will be between F and C of the second mirror. So what happens is, the image will be formed beyond C, that means beyond C of this mirror. So you will get two different images of different magnification. This image, let me call this as I2, this as I1, this is object O. So this image would be longer, as the object this is between F and C of this mirror, right? So two different images. So basically, if you want to find out the number of images, you have to see the number of center of curvatures and you will get your answer, right? Again, a very beautiful question, that what am I going to do is, I had a continuous mirror, and now I am cutting the mirror from here, I am cutting the mirror from here, and now both the parts I am shifting it by very small amount in upward and downward direction. So now the complete mirror was being cut from here. Now both the parts I am shifting in the upward direction, and now this is the new position of mirror 1 and mirror 2. Now again, what happens is, the earlier the center of curvature was here because it was one continuous mirror. Now since I am breaking it, when I finish this circle, I will get the center of curvature of mirror 1 as over here, C1, and the center of curvature of this mirror, C2, over here, right? And let me make the object very small, point-sized object over here. So this O is the point-sized object which is on the principal axis. Now guys, you need to understand one thing, that where is the pole? Pole is actually the geometrical center. So here the pole is this, here the pole is this. We know that the geometrical center of the mirror is called pole. You might be wondering that the geometrical center of the pole should be over here. Incorrect. Pole can be taken as per our convenience. That's it. So this is the pole. Otherwise, this point would be the geometrical center of the mirror. So this should be the pole, but it is not. Pole, we can change it by at our own will. So what am I going to do is, this center of curvature, and this is the principal axis, and I am going to consider this as pole. In the same way, this point I am going to consider it as pole, and this is the pole now, and this is the principal axis. So this, for this mirror, this object is below the principal axis. For this mirror, this object is below the principal axis, and for this mirror, this object is above the principal axis. But anyhow, the object stays at C only. So what happens is, when the object stays at C, it is just like you are looking at this situation. This is C, and you are looking something like this, looking at this object. So this is the object at C, but inverted object. So where would be the image formed? At C, in the upward direction, like this. So if the object is this, then this is the image. But if this is the object, this is the image. So if the point-sized object is below the principal axis, like this, you can consider the head to be point-like object. Then the head of the image would be over here. In the same way, this object's image would be above the principal axis at the same distance, somewhere over here. Let me call this as I1 or I dash. For this mirror, mirror number 2, this is the principal axis, and the object is above principal axis. So this can be considered as the object, and this would be the image. So at the same point, at C only, at the same distance down, you will get the second image, I2 or I double dash. So this concept is very much important to understand. Hopefully guys, you have understood it, and do comment in the comment section and subscribe my channel for more interesting videos. Thank you for watching the video.